Welcome back, guys. So like I said, we are going to be splitting the set operations into two parts, and so this is part two. This is what we are going to be doing today. So we are going to be looking at unions of sets, intersection of sets, and then difference of our sets. So let's look at them in action. Now the first thing I want to do is to create some sets that we'll be using for all of these examples. So for our first set, I'm just going to say 1, let's space them out a bit, 2, 3. Then for our second set, I'm going to say 3, 4, and 5. Good. Now for simplicity, let's call this A, and then let's call this set a B. So we have our set A and then our set B. Good. So now the first thing I want us to look at is our union. Now I'm going to try my best to add in the diagrams doing editing. So union means we are taking the whole of this A and then we are taking the whole of B and then making it as a whole, as one complete whole on its own. So right off the bat, I can predict that our full union will give us a result like 1, 2, 3, 4, and then 5. But we need to confirm it as always. So now let me just print our A. I want to print A union B. Now pay very much attention. I want to print A union B. So this is where you have to pay attention. To actually perform the union, you need our separator like this. Yes. Now this character is usually found on top of the backslash. And the backslash itself is close to the Z character. So yeah, if you don't really know your keyboard. So we print A union B. I'm going to run this. Then we have 1, 2, 3, 4, 5, like I said. So union is just bringing everything together. And remember from the very start, we've been saying sets are unique and all of that. So it's not really going to duplicate these 3 over here. It's just going to overlook it and then have a union for you nicely like that. Now next, let's look at our intersection over here, our intersection. So our intersection simply means when we look at these two sets, what are the common elements between these two sets? What do they share in common? So you realize that we have a 3 over here and then we have a 3 over here. Good. Yes, first let's make our prediction. So if you really understand what I said, you will know that we are going to return a 3. And now I'm just going to print A. And you use an ampersand for the intersection. So A ampersand B. I'm going to run. You can see we have a 3. Oh, sorry. So this is supposed to look like this. Yes, we return a set. So this is supposed to look like this. Yes. So this is A intersection B. This is what A has in common with sets B. Sets A and sets B have 3 in common. Now finally, this last one can be a bit tricky. So difference simply means elements that are in A but are not in B. So kind of how in mathematics sometimes when we want to say subtraction, we say difference. So we want to take out A from B. I don't know if that makes any sense. But let's look at an example. Examples always help lock it in. So if we want to find A difference B, now just think of the difference as a minus, you see. So let's think of it as A difference B, like this. Good. Now let me break it down. Let's actually analyze all of this line by line before we run, so that we'll be able to understand it very well. So when we say A difference B, it's simply like A minus B. So let's even think about it in an actual subtraction sense. When we want our A, we are taking away everything that has to do with B. So first of all of this isn't supposed to count. Now you also realize that this is shared in common with B. So it's part of B. Now again, I'll use the diagrams in editing so you actually notice what I'm talking about. If we had our Venn diagram, this would be in the intersection engulfing B. So this is also shared over here. So basically, any number you find here that you still find in B should not be included in the difference. So again, let me make our prediction. I'm saying this should give us 1 and 2, if I remember my Python very well. So I'm going to run this, and you can see we have 1, 2. Yes. So just elements in A that are not in B. Again, if that makes any sense, good. So now let's do it the other way around, just for understanding. So I'm switching the positions, B and A, and now let's go through this again. So first of all, everything over here is disqualified because we don't want to return it. It's B minus A. We don't want the A, so we've kind of thrown the A away. Good. And again, we'll find that 3 is in common over here. 3 appears in A, but we want elements in B that are not in A. 3 is in A. So again, I'm just going to make the prediction and say we return 4 and then 5. And when I run, you can see that we have truly returned our 4 and then our 5. So I always want the best for us. Let me add one last one. So let's say symmetric difference. So with this one, it's kind of the same thing, but in this case, whereas we will see something like maybe we don't want A or you don't want B, this time we don't want the common elements. So anything that appears across board will just be taken off. You understand? Yes. So let me actually write. So let me just predict again. Anything that cuts across will not be predicted. So we'll have 1, 2, 4, and then 5. That's what we'll be left with. And then to actually do the computing, and then you print A power B. I'm going to call it power. I don't know the actual name, but it's above my key 6. It might be there for you too. So you print this, and then let's confirm. You have 1, 2, 4, 5. Yes, so that's symmetric difference. So that will be it for our sets in Python for the purposes of this course. And then next we are going to be looking at our dictionaries and then our functions, and then we'll start building all of these school projects, and then we'll call it a day on the course.